you should have gotten 2 items in your classroom feed. Well, 3 things, I guess, a calendar and then some classwork items. Those, it's taking its darn time. I did post a video from yesterday. I think it was 5th periods. You should have this electron configuration practice that we're going to do together and quantum number review table. These are both due tomorrow, along with the virtual spectroscopy lab. So this class actually has the fewest people done of any of the classes. So does anybody have questions on the spectroscopy lab? You type it in the chat, you can unmute, whatever you need. Do we need to go back over that? Does anybody need that?
It's pretty easy, I just have to do it.
Thank you, Jack. Jack thinks it's easy. Everybody else? Okay, you just got to do it. It's not due till tomorrow, so, you know, procrastinate a little more. All right. So the other item that's due tomorrow is this. It's just a, it's just a review of what we've done the end of last week and yesterday about the, it's mostly end of last week stuff, but that's when we first went over it. What do the quantum numbers tell us? They tell us the address for the electrons, and then the principal quantum number, the second quantum number, third, fourth. What are they? Just fill this in. You can just type right in here. It's a normal document. And then there's 2 questions. How can we find the principal quantum number? Oops, there's a typo. Using the periodic table. And then how can we find the second quantum number? At least I'm consistent, right? Using, I just noticed that. Using the periodic table. So, and I put a periodic table on there for those of you that don't have one handy. Yeah. So, that is due. This is the note sheet that we got yesterday, where we went over the quantum numbers again. And we talked about these 3 rules. You'll need to know those. And we're going to spend some time doing some of this stuff today after I show you. After I show you the calendar. All right. So I did not get to the discharge tubes earlier, so I'm not going to do them with you. Maybe in January I'll remember to show you guys. So the quantum number review page, it says a journal. Normally we do it as a journal, but it's not today. Sorry, that might be the vet. Hang on. Hello. Hi, Dr. Kane. Is it possible? I'm right in class with my students. So. Can you, yes, about 20 minutes? Okay, thank you. Sorry, guys. So, yeah, so on top of my father-in-law getting COVID and his wife, my stepmother-in-law, the dog's back is all messed up and she's in pain and panting and crying. Well, where was I? Quantum numbers. Electron configuration, we're going to do that. We already talked about spectroscopy. Okay, so Thursday is a part of the quiz with, or part of the final. Thank you, Bella. I appreciate that. I really, really do. Everybody, it's just kind of crazy, you know. I lost an uncle in September. I lost my aunt in November. Horse last Friday. My dog and my father-in-law. Ah! Can't do it. A little bit longer. Partner final is going to be random. There's going to be calculations you need to do. You absolutely need your calculator. You need a piece of paper and something to write with. I want you to upload an image. I'm just going to do one image at the end, like Mrs. Huffer does on her math tests. So you don't have to, it's kind of wonky, I know, to have to do that. If you don't know how to take an image with your phone or some other device, I know not everybody has a phone, you can try and figure out a way to send it to me as an email so you get credit. Okay, I want to make sure that you understand that's going to be points, and you need to send me an image of your work even though you're working with a partner. Friday is going to be all multiple choice, and again, you can have a cheat sheet, and I mean a sheet, a full piece of paper, back and front if you want. I'm totally fine with that. Handwritten your stuff. I just ask that you don't communicate with other people, and you don't go on the internet to search, and you don't look in your book. But academic integrity seems to be going out the window these days, but please, I trust you guys, please don't cheat. So, is that it? Okay, something else I wanted to tell you. About 60 points each day. I haven't actually made it with all the stuff that's been going on. I haven't made the full final yet, and so I promise you there'll be a calculation on density, kind of like what we did with the aluminum foil lab stuff, and the nails. There'll be a calculation of frequency from the wavelength equation, C equals lambda nu. There'll be, so you need to know the speed of light. There'll be a calculation with the energy equation with Planck's constant, 6.6262 times 10 to the minus 34th joules times seconds. You got to remember sig figs, you got to remember units. You got to know how to use a scientific calculator. Half of it, roughly, will be the last two chapters that we've done. Chapter 25, all the nuclear chemistry stuff, and Chapter 5, the stuff on boors, atom, and electrons, and light, and electron configurations. It's a lot, okay? That'll be about 50, maybe a little bit more. The stuff that we've done November and December. The stuff prior will also be on there, both days. But again, 50% or less, a little bit less maybe. So we've already had assessments on those. I just got to check a few things to make sure you remember what observations are, and quantitative and qualitative, and that kind of stuff. And lab equipment, there'll be a picture of a piece of lab equipment you've got to name correctly. And, yeah. So that much I know, okay? Tomorrow, I'm planning office hours from 10 to 11. I'll send out a Zoom link like I did last Wednesday when nobody showed up. Maybe with a final imminent, people will show up. If you don't, it's fine. It's totally fine. I will try to sign on Thursday, full 5 minutes before the final starts, so you can ask me questions right away if you have any. And again, you'll be randomly put with another person in a breakout room. You'll need to have your cameras on, all that kind of good stuff. I've offered earlier today, I know other teachers are doing office hours. I know you may need to go to a different teacher's between 10 and 11. You can drop in at any time. You don't have to be there for the full hour. But if I get messages from people that they need 9 to 10 as well, or instead of 10 to 11, I will be open for business at 9 o'clock if you guys need it. Okay, so let me know either in the chat today or email me if you'd like me to start the office hours for you. Okay. All right, questions on the final, on any of the stuff I just went over? All right, if there are none, then I'm just going to jump to where we left off. And remind you that the periodic table has a lot of information on it. Oops, that's the wrong pen. I messed that up. Sorry. And again, the periods correspond to the principal energy level. Energy level 1, energy level 2, 3, 4, 5, 6, 7. Okay? So that's a start. Remind you that regions or blocks on the periodic table correspond to the second quantum number, the sublevels. Okay? Remember, on the periodic table, you imagine that the nucleus is up here. The first layer is the 1s orbital where hydrogen and helium live, etc. And go back. Somebody please have a question. Oh, no, it is there. Okay. All right. So, I'll go back. Sorry, I thought someone. All right, I'm not going to do it. So, here we go. Do we know what's going on? I am presenting. You guys can see this, right? Okay, thank you. Right. I don't know why it's chiming at me. Oh, now I just open iTunes like an idiot. All right, so I'm going to keep moving. This is kind of where we were leaving off, so I want to. I don't know what is going on, but I'm going to just keep going. So I'm going to do an example and try and show you the process. Remember, on the filling diagrams, they're nice, they're intuitive. The lowest energy is at the bottom, the highest energy is at the top. This is like our little nesting dolls, right? Remember, the 1s is tiny, the 2s is bigger, 3s, 4s, 5s, 6s. They're all the same shape. They're all spherical. And then the peanuts, the dumbbells, are the p's. They don't start until the second energy level. And there's the 3p's bigger, the 4p's higher energy, 5 is highest, 6, etc. Okay, and then there's the D's and the F's. Everybody good, I hope, with that. So the next thing we need to do is pick an element. So I'm just going to pick the element sodium. That's another thing you got to remember for the final is there'll be some symbol of an element and you have to match it with the right name and match it with the right element. And remember, sodium is from the Latin natrum, so it doesn't start with an S, okay? And so you need to be careful. But sodium, when we look at it, go back to the periodic table, lives, okay? And sodium is on the 1, 2, 3rd line. It's in the S block. Ugh, that was bad. So its last electron goes into the 3s orbital, and since sodium's in the first column, it's gonna end, its electron configuration ends with 3s1. Okay, P blocks over here, D blocks in the middle. We won't do anything with the D block elements until after grade. So what does that tell me? Okay, so we go back here. Oh, and I forgot to tell you it was element 11. So since it's element 11, that means it has 11 protons. If it has 11 positives, it's got to have 11 negatives, 11 electrons. All of those electrons have to live somewhere, and there's rules to where they go, okay? And so we're going to review that real quick. So also, 3rd energy level, or principal quantum number 3, S block, sublevel S, and there's 1 electron there. Knowing where the element is on the periodic table tells me where its last electron goes. So remember, Pauli exclusion principle said no two electrons can have the same address, the same 4 quantum numbers. One of them has to spin one way, and the other one has to spin the other way. And it doesn't matter, okay, the little slash lines. You can use the up and down arrows too, it doesn't matter. Okay, whatever makes you happy. But I know there's 1 here. Right? The other thing I know is, according to the Aufbau principle, I have to start at the bottom, right? I have to build my foundation. So this orbital has to be filled, this 2s has to be filled, all three of the 2p's have to have all their electrons before I can put anything in the 3s. So it makes it simple. 1, 2, 3, 4, 5, 6, 7. I can't emphasize enough that you really should be in the habit of doing them all the same way before you start doubling up. You know how it's kind of like counting, right? So make them all go the same way before you double up. It won't matter for this one, but if there's a situation where it's in the P block, you don't want to double it up. So, and then double check yourself, right? There's 2 electrons here, there's 2 here, there's 6 and 1, 2 plus 2 plus 6 is 10, plus 1 is 11. We've got it all. So this is also, remember, this is Kunz's rule. Fill them up halfway, okay? Seats on the bus, keep, just everybody gets their own place before you have to double up. So what do I have? I have in the 1s orbital, I have 2 electrons. In the 2s orbital, I also have 2 electrons. In all 3 of the 2p orbitals, px, py, pz, I have 2. So 3 times 2 is 6. And then the last lonely electron far away from the nucleus, that's going to be really important next semester. There's an electron hanging out at the 3rd energy level. So this is electron notation, configuration notation. So we have pictures, and then that take up a lot of room, and then we can do them like this in a straight line where they don't take up so much space. 2 plus 2 plus 6 plus 1, that's 11, and we're done. This one. So same thing here. If we did sodium again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1s has 2, 2s has 2, 2p has 6, 3s has 1. The tricky part, and you might notice, is that all the s's are in the right order, all the p's are going to be in the right order, but there's this weird thing with 3d. And what happens is, I tried to explain this yesterday, the 3d has 10 electrons, 10 negative things that have to all coexist together. They don't want to, right? They're repelling each other. The 4s only has 2 electrons. So yes, it's a higher principal quantum number, but it has slightly less energy for those electron positions. The 4s is above the 3s and above the 2s and above the 1s, but this little 3d thing slips in between the 4s and the 4p. And when you go back to the structure of the periodic table, the first energy level is just 1s. The second energy level, you've got 2s and the 2p's. The third line has 3 s's and 3 p's. Then we go to 4s, but this right here is the 3d. Just a little bit higher energy, and then we go back to 4p. Okay? And if you don't get that yet, it's okay. We'll go over it a bunch when we get going in January. Again, it has to do with having 5, remember those daisies with the donuts thing, 5 orbitals, 2 electrons each. That's a lot of negative energy to try and keep together. Okay, so let me show you, let me see if there's any questions. And let me, get rid of iTunes. Okay. It's one of those weeks. Right. Anybody have questions on that right now? It might clear up when we get to
So you chose sodium, so you have N11, but then
It's Na11.
yeah, sorry, just the 11th number. So, but then you did 11p, and is that because it was in the first row?
11 protons.
Yeah.
That's what the 11 means. It's the atomic number is the number of protons in the nucleus. So there's
Yeah.
11 protons and 11 electrons. It's the electrons we're positioning. All the protons are in the nucleus.
Okay.
And then those superscripts, I think you'll see. Ask me again if it's still not clear, but let's try this one. So hopefully you can open this up. If you can, you can just pull off a tab and have it open along with my explanation so you can see it all. I strongly suggest you do that. All right. I'm not sure. Oh yeah, this one still has 2 extra slides. So I think I took off 2 slides for you guys, or I thought I tried to, but it's still on there. You're going to do 2 examples, and then you're going to do 1 on your own. So the first slide is periodic table and the blocks for you, just to review. Remember, you can zoom, click on the magnifying glass, and click on the object. You have to unclick the magnifying glass. Okay, let's pick, let's do aluminum. Okay, so aluminum's right here, and aluminum is element 13. Okay, aluminum's on 1, 2. Oh, I'm jumping again. Let's go back and do nitrogen. Okay, let's do something simple first. So here's nitrogen, number 7. 1, 2, it's on the second row. It's in the P block. So on this second slide, up here, you're going to put in N for nitrogen. You're going to put in 7, because that's its atomic number, the number of protons. That means it also has 7 electrons. It's on the second line, the second period, second energy level. It's in the P block. That's its sublevel. That's the shape of its last orbital. And it's in the, go back to this really quick. It's in the 1, 2, 3rd column. Okay. So the last electron goes in the 2p. And then remember, use control period to get a superscript. 3. That's not cubed. Okay? That's 2p3. In the second p orbital, second energy p orbitals, there's 3 electrons. That's what that means. And you need to hit control period to get out of that again. So here's our expanded diagram. Remember, the nucleus is down here. I know its last electron is going, there's 3 of them, and they're going into the 2p. So these little blue boxes represent the slashes for 1 electron, and I couldn't figure out a way to do them, to make them overlap. To fill in, so you're just going to have to drag and drop them, or however you do it. Use my arrows. Okay. So I know the last bit of the filling is 3 in the 2p. I also know, because the octal, this one and this one are full. So then I made some X's, which represent 2 electrons, 1 spinning one way and 1 spinning another way. And you can drag, you can copy and paste, whatever works for you. Okay. So the filling for nitrogen, the 1s is full because you have to fill your foundation. The 2s is full, and 1, 2, 3 in the 2p. All right. Same process for, it won't be as pretty. I'm just going to do this fast. Same process for doing the compact filling. They're a little too spread out, so I'm sorry. Let's see if I can overlap it. Smush it together, and then grab a double up one. And again, a little tricky. Paste. Okay, so 2 and 2 and 3 make 7. This is going to be written in shorthand, if you will. 1s, control period 2, control period space, 2s, 2, 2p, 3. These exponents aren't exponents. They're just the body count of electrons. 2 and 2 and 3 is 7. Okay. Questions?
Yeah, okay, so I'm getting it, but so you find out that it's 2p3 by how? That's the only part I don't understand.
That's the tricky part. So it's nitrogen on the 1, 2 second line in the P block and the 1, 2 third column. 2p3.
So the P block is that like everything that's not disconnected or what?
The P block, look down below, are these 6 columns.
Oh, okay.
Good questions. Help it clarify for others. All right, now let's try aluminum. Okay, and so aluminum, go to the third slide. Aluminum's element 13. And my boxes aren't big enough. So I just know that it's element 13. I'll show you on the periodic table here in just a sec. And we'll go back up to periodic table. You can just stay put. You don't have to move around, just look at mine. So here's aluminum, right underneath boron. It's on the 1 to 3rd energy level, the 3rd period. It also is in the P block. Okay? So it ends with 3p1. So 3rd period, P block, 3p1. Its last electron, it's going to go 1 electron into one of the 3p orbitals. Everything else has to be full, so all of these others, grab a couple here, are going to have 2 electrons each. And the 2p is also going to be full. Let's see if I can do 3 of these at a time. Come on, that's fine. So what does that mean? The 1s has 2, the 2s has 2, the 2p has 6, the 3s has 2, and the 3p has 1. 2 and 2 and 6 is 10, plus 2 is 12, plus 1 is 13. I'm just going to skip to the chase here. 1s, I would like you to do the compact filling diagram. 1s2, 2s2, 2p6, 3s2. Oops, gotta get out of there. 3p. Oh no. So instead of taking up gobs of space, like this diagram and even this one, we can make it all nice and neat and tidy in a little secret code that only chemists know. Questions?
Can you go back to the first slide, like the equation thing that you wrote at the bottom?
The periodic table one?
No, sorry, the first example. Right.
Yeah.
Thank you.
You're welcome. And here's the second one again. I haven't done this part, but I'm just saving time because we're running out of time. And then the last one is the one I'm going to check that I want you to try, and I would like you to do silicon. Si. That is element 14, right next door to aluminum. So that's easy. Oops, not 15, 14. And I will show you the correct answer so you can check your work before the quiz if you need it, or you can come to office hours tomorrow and I will go over that. Questions right now that I can answer? So it's weird stuff. I know it's really crazy. Do what you can. Hopefully between you and your partner on Thursday, you'll get some clarity too. If you want to stick around and ask questions after, you can. If you don't need to, make sure you get those, get this thing done, get the